The demand equation for a certain brand of headphones is 100x squared plus 9p squared equals 3,904. I already like this problem because we are given our equation. We don't have to remember the volume of a sphere or a cube or anything like that. It's given to us. Here's our equation that relates everything. We have where x is the number in thousands of headphones demanded each week, and p is the price. We want to know how fast the demand is increasing when x equals 4. The unit price per headphone is $16, and the price is dropping at a rate of 10 cents per headphone per week. So our equation, let's copy it down and then do our same setup we've been doing. So our equation is given to us. This relates the demand with the price. So as I'm copying this down, let's think about demand and price. If the price is going to go up, what should happen to the demand? So if you see that gas has gone up to $10 a gallon, you are going to ride it out on E. Whereas if gas goes down to 15 cents, you're going to fill up even if you already have 3/4 the tank. So if price goes up, demand should go down, and when price goes down, demand should go up. So we can kind of get a feel for this even though it's not volume and side length or anything like that. So there's our equation. We have X, which is thousands of headphones. So I'm just going to write 1,000 headphones just so we remember. And then we have P is the price. So this one's in dollars, since it's not like centimeters and centimeters cubed. I want to write down the units. And then my time here is in weeks when I take the derivative. So I want to know how fast is the demand increasing when x equals 4. So it doesn't mean they're selling 4 pairs of headphones. That means they're selling 4,000. And so from that, we're going to get our dx dt when we take the derivative. And then we have our p and our dp dt, which we should also write in here too. So dx dt is going to be in thousands per week, because x is in 1,000 headphones and t is in weeks. And then our price is going to be in dollars, so this is going to be in dollars per week for dp dt. So x is 4. The unit price per headphone is $16 right now. But we're going to do something to it. We're going to drop the price at a rate of 10 cents per headphone per week. So we're going to drop the price. That's our dp dt. We're changing it by 10 cents per week. So we're going to put a negative, because we're lowering our price, and 10 cents. I'm going to write that in dollars. So I'm not going to write just 10. It's going to be 0.1 or 0.10 would be 10 cents per week. So negative 0.1 stands for that dropping of 10 cents per week. And I want to know what's going to happen to the demand. It should go up. So we'll see if that's true, because they're not dropping it very much, but maybe it'll still go up just a little bit. It's like if the newest iPhone went down on sale for $1, everybody would buy one, even if they didn't need a new phone, and the demand would go way up, because that'd be a huge price drop. We're only dropping by 10 cents. Let's see what happens. So now that we have our whole setup, we're going to take our derivative, the derivative of 100x squared with respect to time. We'll bring down 100 times 2 is going to be 200x dx dt. Bring down the 2, 9 times 2 is going to be 18p. With respect to time, I need a dp dt. And then I don't want to forget to take the derivative of the right side. Derivative of 3,904 is just 0. So there is my derivative. My next step would be to plug into it. I'm going to plug in everything I know, and I'm going to solve for the derivative that I don't. I know what's happening to the price. I know dp dt, and I want to figure out what's happening to the demand from that. I'm solving for dx dt for this one, but I should know everything except for dx dt. So I'm going to plug in. I have 200 times my x value. There's currently 4,000 headphones demanded per week, so there's the 4. Times dx dt, I want to figure out what that is. Plus 18 times my current price in the headphones is $16. Times my dp dt, we're dropping it, we're doing a negative $0.1 per week. That's dropping it by 10 cents. So now I can multiply these out before I even try to get the dt by itself. I can just multiply these constants. 200 times 4, 2 times 4 is going to be 8. So I'm going to have 800 dx dt. Then I have 18 times 16 times negative 0.1. So this is actually going to be a negative 28.8 equals 0. Now I want to get dx dt by itself. This looks like a linear equation in mx plus b. So I'm going to add 28.8 over to get rid of that negative 28.8. I'm going to bring it up here. So I have 800 dx dt equals 28.8, because I would add it to both sides. And then I want to get dx dt by itself still, so I divide by that 800. So I want to do 28.8 divided by 800. And when I do that, I get 0.036. And I want to remember that this is in thousands of headphones per week, which doesn't really make too much sense to me. I would actually multiply this by the 1,000 in my calculator just to see how many headphones that really is. So if we multiply it by 1,000, we're moving it over 1, 2, 3 places. This is really 36 headphones per week. So what's happening? We start out with what we know. The price is dropping. So as the price drops 10 cents per week, the demand does what? What did our derivative say? It's positive, so it increases by 36 headphones per week, which makes sense. We're doing such a small price change, but since we're decreasing it, our demand should increase. So we drop the price by 10 cents, 36 more headphones are sold that week.